So now that we've talked about the API gateway pattern, let's talk about how we apply that pattern along with the Spring Cloud API Gateway platform in the context of our QuoteServices app case study. And we're going to see how we're going to do this by focusing on this piece of the puzzle, the gateway microservice part. Once again, this code is almost entirely declarative. There's very, very little code we have to write with Java syntax, and almost everything comes out of a YAML property file. So the Spring Cloud API Gateway consists of several components. And this is just a nice little diagram from this link, which I highly encourage you to read, that kind of shows the overall structure of a Spring Cloud Gateway. So clients send requests. There's a gateway handler mapping thing, which looks at predicates and filters and so on, and then routes the filtered requests to the appropriate microservice. So the first and the main concept is the concept of a route. And what is a route? A route consists of an ID, which is typically the name of a microservice, a destination URI, which is how to go find that microservice, a collection of predicates, which, as we'll see, are ways of being able to identify a particular microservice, and a collection of filters, which says things that you do to the microservice, to the URI that's come in to the request before you send it on. So here you can see this is a little snippet of code that we'll talk about later, because this is straight out of the gateway example from our QuoteServices app. And we define routes with IDs, like handy and zippy, URIs, which is the places these things are listening for requests, predicates, which are ways to be able to identify that a given URI corresponds to a given microservice, ID, and then filters, which, as we saw before, will strip stuff off before forwarding the requests onto the microservice. A route is matched if the aggregate predicate is true. So if something comes in and it's got the handy path as the route name, that's going to match. It says, ah, this is something I know about. This is the handy, this request is for the handy microservice. And you can either create these routes programmatically using Java or whatever is your favorite language that works with Spring, or declaratively using YAML. So I chose to use YAML. I find it way easier, although there's a few little tricks. You have to be very careful with how you indent this stuff, because if you don't indent it properly, you'll get strange errors that are mystical and hard to understand. But if you do it right, then it works fine. Predicates are used to match the incoming HTTP requests. You can match all kinds of different things. In this case, we're just matching on the path portion of the URL. So this will match handy or zippy route names in a path. So that's how we specify the predicates. And then filters can modify the request or response as per other requirements. And here's an obvious one. We want to be able to strip off the name of the microservice before we forward the request to it, because the microservice doesn't need to know its name. It knows its name. It doesn't have to have that as part of the URL that it's passed, or the URI that's passed to it. So that's what the filter does. And there's all kinds of other things you can do with filters. OK, so given that as the background, now let's take a look at how we actually implement this stuff in the context of our QuoteServices app and the gateway microservice therein. So the QuoteServices app is going to use the Spring Cloud API Gateway, which we've just been talking about, in conjunction with Eureka. So we use Eureka for the server-side discovery to register everything, including the gateway, by the way. And everybody registers with Eureka, and then the gateway is going to handle the requests that come in. The gateway is configured almost entirely using declarative YAML files. So here's the application.yaml file. This is the one. You can find this in the Gateways Resources package. And as you can see here, it says, I am the gateway, and I am going to list it on port 8080. That's the public-facing port that's exposed to external clients. And I'm going to have an active path profile, so take a look at stuff that comes in and parse it out properly. And down here, you can see that the gateway also says, I am a Eureka client. Please fetch the registry. And then here's the place to find the Eureka discovery service. So that's the host name, the port number, and the name of the service. Don't have to do it that way, but that's how I did it for my simple example. Then we also have something called the application path YAML file. And this is what's used to define the routes. So this is the routes for this gateway, because we already said what the gateway was. That's that guy. And over here, we're defining the Spring Cloud Gateway routes. And this, again, just explains what the IDs are, the URLs, the URIs rather, the predicates, the filters, et cetera, et cetera. All those kinds of good things. And then that's read by Spring, by its gateway, cloud gateway mechanism, when the application starts up. And then it builds all these tables internally to do the route mapping for us automatically. So again, there's almost no code that we have to write in this example at all, which is really, really powerful. OK, so let's take a look and see how all this works. So the gateway uses the Eureka microservice to locate the other microservices. It encapsulates by name. So a client sends a GET request, which arrives at the gateway, assuming everything's been pre-configured. The gateway then goes out and parses out the routes. It figures out what it's got. It says, aha, I've got something for the handy microservice, or I've got something for the zippy microservice. And then it goes and says, hey, Eureka, do you know anything about the zippy microservice? Do you know anything about the handy microservice? And Eureka says, sure. These guys have already registered with me. And so it tells the gateway where to find those microservices. And then the gateway will transparently route the request to the designated microservice after first stripping off that part of the request that's the name, because we don't care about the name, that the services know their names. Then the designated microservices controller receives the request, and it, as usual, will forward it to the service, and that'll do the work, and then it'll go ahead and send the result back to the client, bypassing the gateway. So coming back from the microservice to the gateway, sorry, to the client is a direct shot, doesn't have to flow back through. So there's only the indirection overhead when things come in to do the routing. So that's the end of our discussion of the gateway microservice structure and functionality. Now, of course, we will look at this code in more detail, and you'll get a chance to see how it all works shortly.